All right. Good morning, everyone. Thank you for joining us today. My name is Naomi Newman. I'm with 3C Ren. As you've seen, I've started recording this course. It will be posted on our on-demand page after, and you should get an email copy as well. Today, we have Jennifer Rennick and Grant Murphy from Imbalance Green Consulting. They're going to walk us through the energy code implementation for accessory dwelling units. And before we get going, I just have a few slides to run through. So if you could change to the next slide, Jennifer. I'm sure everyone is very used to being on Zoom now, but we just ask that everyone make sure they're on mute throughout the duration of the course. If you'd like to verbally participate, please raise your hand and we will call on you and ask you to unmute yourself. And we encourage you to participate and ask questions in the chat throughout the lesson today. Next slide. And just a couple of words about 3C Ren. We are the Tri-County Regional Energy Network, also known as 3C Ren. It's a collaborative partnership between San Luis Obispo, Santa Barbara County, and Ventura County. And we work to improve energy efficiency in the region by offering free programs and services for building professionals and households. We're funded by ratepayer dollars that are collected through the public goods charge that are on all our utility bills. And the benefit of this is that there's no cost to those that we serve, and we're able to return these dollars to the local community, which has historically missed out on some of these funds. And we currently offer 3 programs: Energy Code Connect, Building Performance Training, and Home Energy Savings. So Energy Code Connect, which is what brings us this course today, serves building professionals by offering trainings and support to make the energy code easier to follow. Within this program, we offer the Energy Code Coach service, which is an over-the-phone, online, and in-field support for Title 24, Part 6, and Part 11 related questions for both residential and non-residential projects. And we also offer online courses, like this one, as well as regional forums, which aim to increase the overall energy code comprehension, compliance, and enforcement. Our second program is Building Performance Training. This serves building professionals such as architects, engineers, contractors, and real estate professionals, and offers technical and soft skill training related to building science principles and high performance buildings. And our last program is Home Energy Savings. This incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll pass things over to Jennifer.
And welcome, everyone. This is the third course in a 5-part series on Title 24 2022 Energy Code changes that took effect in the beginning of January 2023. So now we've had over a year to work with the code. And what we're trying to do with this series is just point out the areas that seem to be the most problematic, or areas where folks need more clarification or help, or wanting to understand the code a little better. If you all would, could you put in the chat for me? And Grant's going to monitor that. If you're an architect, or if you're a plans examiner or building professional, or maybe you're a homeowner. So, and the reason I ask is for ADUs, accessory dwelling units specifically, will get a fair amount of homeowners. And I want to hit a couple of things, touch on a couple things for homeowners, but also if we're predominantly architects today, then we can get more into the design side, details and things you want to pay attention to as architects. So yeah, okay. Oh, great. Someone from TRC, yay. Case studies, that's great. It looks like we've got mostly architects. Okay, that's good. And then anyone here who's, not an architect, but you're shy to say, that's fine too. Then use the chat, and Grant can answer your questions as we go along. For those of you that are AIA architect or part of the ICC plans examiner, you do get learning credits today. So give your numbers if you haven't already done so, give your numbers to Naomi so that you can get those units logged. Today, we're going to give briefly this 2022 code kind of overview, set the stage. A lot of that's review. It's like really review by now, but it kind of sets the stage of where we're at for ADUs. We're going to dive into a little bit on the ADU resources, some definitions. A lot of us as architects are familiar with how these things are defined. However, it might be slightly confusing to your clients and homeowners, and it might give you some vocabulary to better understand what they are coming to you and trying to do. And then we're going to hit on some of the areas that are a little bit confusing on how to implement the energy code when it comes to whether this is considered new construction or whether we're talking about additions and alterations. And those three categories will affect our walls, windows, our hot water, and a couple of concerns and possible ways of getting credit under Title 24, specifically with heat pump, space heating, and balanced ventilation. So big kind of picture overview. Yes, California Energy Code implements energy code update every 3 years. So we're under the 2022 code currently. And this code, through the code language itself, is encouraging heat pump technology, both for space heating and water heating, as California moves towards all electric construction. As California gets an electric grid that is being supplied by renewable energy, both solar, wind, and battery system to stabilize the grid, then it makes sense for California to encourage all electric construction. You don't have to, that's just where the code is going. The reminder that previous code, 2019, the code was roughly organized, kind of all buildings, high-rise residential along with the non-residential sections, and then low-rise residential. The code's been updated for this current cycle where the multifamily sections have been pulled out from the non-res and the single family. Today, for the ADUs, we're going to focus mostly on the single family ADUs. Next time we do this code, we're going to hit on multifamily, and we'll touch on ADUs specific to multifamily during that section. Real big picture reminder for any of you that are new to this: mandatory requirements are always required for the project. And then we have prescriptive component package. This is going to come up when we talk about what's required, especially for additions and alterations, because prescriptively, if you follow the recipe card, you follow everything in the checklist, you can comply with the energy code that way. But often that recipe card doesn't work for a lot of folks with small ADUs, specifically when it comes to window sizes. So you do have an option, and you can use a computer energy model known as the performance approach. And so we'll touch on a couple of credits that you can take for that performance method. And then in the performance method, kind of big takeaway for this 2022 energy code is the use of heat pump systems for space heating and water heating. And so I wanted to give you a quick little visual of what this looks like most of the time, where we're going to be talking about ductless mini split systems or a fully ducted system, but it's still split. You'll have an air handler inside and the compressor condenser outside, and it does both heating and cooling, as opposed to a traditional system you might be used to thinking of where the air handler also doubles as your furnace. And you had the outdoor unit is strictly cooling, air conditioning. So with ducted split system heat pumps, that air handler strictly is dealing with air, and then the outdoor unit does both your heating and cooling. And then similar for water heaters. Okay, now when it comes to ADUs, I threw this in here in case anyone's new to the code, but also in case we had any homeowners on here. And the reason I bring this up is because now there's a push for pre-approved or pre-reviewed ADUs. And so, like all new construction, you in order to get your permit, your homes have to go through a home energy rating system. The plans are uploaded to either CalCerts and Cheers, and you as the architect sign off on it. If we're doing the energy analysis, for example, or your Title 24 consultant's going to also sign off on it. And then your HERS rater's going to get all the documents from the HERS registry that show that they complied with the installation and the verification. And then your building official can confirm that those CF2Rs and CF3Rs are uploaded and signed. So for the accessory dwelling units themselves, California has been pushing for, pushing, I don't know if that's the right word. Let me back up. California has implemented policy changes to make it easier for people to build accessory dwelling units and to stop local communities from precluding them. And they've been wanting to, and this has been going on for a while now, because they're more affordable. They can give you a family connection, flexible living spaces, and often rental income. What's going to be new coming up for January 2025 is that building and planning jurisdictions are to have plan sets available. So you as an architect, you might be part of a team that has been contracted to create these plan sets, or what we think will happen is that in many cases, if their project doesn't exactly fit the parameters of the pre-reviewed plan sets, then they may need to reach out to an architect to modify the plan a little bit, and in which case they would have to resubmit just like you would for any other new construction. And I believe that's correct, Grant. Is that, yeah, Grant's nodding. He's muted, but yes, he's nodding just to confirm. And so on our side of the Title 24 compliance part of it, for the architects and the plans examiners out there, you might get a phone call about this. And one thing we're noticing that homeowners are not aware of is they don't quite understand that HERS registry I just mentioned, and they don't know how to look at a Title 24 document, the CF1R, and really understand if any special features and HERS measures are required, and that they will need to hire a HERS rater. So that is something maybe to help your clients, especially if they come to you with this. The great ADU resource is the Accessory Dwelling Handbook, available with the Housing and Community Development. So you go to their website. The handbook's got a lot of commonly asked questions, and they give a great definition of an accessory dwelling unit. Independent living facilities. So if you find that you're getting asked these questions, you can direct the homeowners to this handbook, and it might take care of a lot of their questions as you also are helping them with their project and with the design. One of the biggest things I think for an architect to be aware of is that the ADU does have the independent bathroom facilities, but it also must have its own heating and cooling system that does not share air with another dwelling. which is a little bit different than the junior accessory dwelling units, where those are going to fall under alterations, and they're a conversion of existing space that's less than 500 square feet. And they may share a central HVAC system, and they may include shared or separate sanitation or bathroom facilities. So the common allowable ADU and junior ADU types in the language of planning departments and the policy and those housing regulations, and you'll often see something referred to as a detached ADU. That's new construction. And you might also see attached ADUs where it's internal to the existing space, like a basement remodel or conversion, or a loft or attic conversion remodel. Or it could be that you have an existing structure that's converted, and so in that case it could be eternal or detached, but it's a conversion. And then you could have something that's just a straight up addition where it's now attached. But in the language of the energy code, only the detached type up above is considered new construction. So when you're using the energy code, you're building a separate unit in the back or side somewhere on the property. Everything's new, you haven't converted anything. That's going to fall under the single family new construction standards. And if you listen to our presentation before, there's going to be a little overlap because those new standards apply. And then every other type of addition, conversion, alteration, remodel, all those things, that's going to fall under our alterations and additions part of the energy code. So with that, one of the biggest things that come up on our Code Coach questions. Oh, I failed to mention. Geez, I just jumped right in. I didn't really even say, hey, I'm a licensed architect and certified energy analyst and your code coach. Grant does commissioning and is a certified energy analyst and is a code coach for 3C Ren. So one of the questions we get through the code coach is, hey, I'm building an ADU. Do I have to put solar on my ADU? And so then we ask them the questions of, is the standalone, new construction, detached? Are you converting anything? And the answer is maybe, depending on the size. And there's so those regulations can be found in section 150.1. For everything else that's like that's an actual addition or a garage shop conversion that's detached or an attached shop conversion, these things would be considered additions and no PV required, for example, but you could add a second water heater if you wanted to. And then alterations that do not increase the conditioned floor area under the energy code. This could very much be like a junior ADU condition. And that junior ADU would be built within the walls of the existing residence. So you're not doing any formal addition as in increasing your floor footprint and volume or site. And then now all of the alterations part of the code is going to apply. Any, before I jump into this next section, any questions coming into the chat? And I tried to zip through that as quickly as possible because most of us on the call are architects today. So just, if I went past anything too quick, just let me know.
No questions yet.
Okay. So when it comes to the new construction, so the detached standalone ADUs, that answer or the question about do we have to install PVs? And the answer is maybe, depending on the size, depending on the conditioned floor area of the new ADU dwelling unit. And I threw this slide in here so that you could have this formula handy. And it's based on your climate zone. And the common ones we're dealing with for Santa Barbara County, San Luis Obispo County, climate zone 4, 5, 6, and 9. You can run this little calc and see if the PVs are going to be required. As a plans examiner, and you might get this on your plan check, if you're trying to take the exemption for PVs on your Title 24, you may want to include this calculation and this formula. Basically, what I've put on the left-hand side, you may want to include that in your plan check or your plans to show that, in fact, you do not need PVs. And that is triggered if the PV system is less than 1.8 kilowatts. So, for example, at 1,000 conditioned floor area, square foot ADU in climate zone 6, so down in Santa Barbara, they may need to put, or they will need to install a PV system because the formula gives you 1.82. 1.82 is greater than 1.8. You know, and so PV systems required, that's about 6 residential panels. If each of the panels was about 300 watts, and you would design for that. If you don't want to do the PVs for climate zone 6, for example, you may have to reduce the square footage of the ADU a little bit. So one thing we've coached some of the planning departments for their climate zone is just to calculate where that threshold is, so that they can see that if the ADU is bigger, they should be showing PVs. If the ADU is smaller than that, then PVs aren't required. But I'd recommend putting that on your plans. There's a couple other ways you can avoid the PVs, and that has to do with if the solar area of the roof is less than 80 square feet. And if you're going to use a battery, you can reduce that PV size by 25%.
Jennifer, we have 2 quick questions.
Yes.
One is if there's an exemption for lack of solar access.
Yes, there is. And that is, yes, if you do not have solar access because of like a huge hillside, where it's a permanent geological feature, you can work with your planning to building department. It might be really obvious in some cases that you won't have solar access, but otherwise you would hire a PV consultant to use software that's been approved by the California Energy Commission that shows, hey, you don't have enough solar access, and then you could be exempt for that.
The second one is when you're doing a garage conversion ADU, if the second water heater is optional, if you can tie that garage ADU conversion into the existing home's water heater.
Yes, you can. It's optional.
Great.
Yeah.
Thank you.
Yeah. So it kind of depends on how really independent do you want it, and also maybe depending on the existing water heating system you have.
Now you can't do that with the forced air unit though.
Correct. Just a water heater.
Yeah.
To the air that you breathe and your fresh air and your recirculation air that may be part of your heating and cooling system, the airs shall not intertwine. But you're not recirculating, reusing your hot water, so you're good.
Perfect.
Okay.
Thanks.
So energy storage systems, i.e. battery ready, that is a concept that's only applicable to new construction. So this slide, next couple slides, we're just talking about new construction standalone. The infrastructure is mandatory, but installing the battery itself comes as a potential performance pathway extra credit. And it needs, if you do install it, it needs to be able to interface with the grid. So we are talking about grid tied, meaning electric, tied to the main, like PG&E, or if you're on a different SoCal Edison or microgrid, it's got to tie back to that. And the performance credit we're finding out is relatively small, but it does exist. And combining that battery with your PV system is typically where we're seeing the whole thing to be cost effective. So adding that battery to the PV system for your clients to look into that, the homeowners to look into it, because that's where the cost savings or the cost effectiveness of that PV system is coming into play under the current rate for solar. The battery ready infrastructure that's required to go with that includes interconnection equipment, dedicated raceway. So typically you're going to have your main electric panel and then a sub panel for branch circuits with that dedicated raceway. And then you will have a space allocated that's within 3 feet of your panel for a future transfer switch. And that's to just make it as easy as possible to install a future battery for this project. There's some other requirements that just say, hey, those circuits, those branch circuits have to be identified. And they only call out 3 that you have to have. And then so the 4th one is your choice, but it needs to go to your refrigerator, at least 1 light near the primary egress, and a sleeping room receptacle. So the main panel, it's the way the code's written. It says the main panel must have a bus bar rating of 225 amps. There has been some clarification on that, specifically coming up with ADUs, because a lot of times you're going to have a main house that's going to be drawing more power than the ADU, but it's the new construction ADU that's triggering this large panel, or at least the 225 amp bus bar rating. So I included some clarifying language from the CEC through their blueprint newsletter, and they have the frequently asked questions section. And so I put this in here for your reference, but the bottom line is that you can install a smaller electric panel as long as the bus bar rating is clearly identified that 225 amps is marked, and you're able to have that bus bar rating at the house. And you also can put that on the main residence and then sub panel to the ADU. And that still meets these requirements for that new construction. Part of the mandatory requirements for electric ready is if for some reason the ADU, and again, this is the detached, standalone, new construction ADU, for some reason, the homeowner decides not to go all electric and wants to install some gas or propane appliances, then like new construction, you have to design the space to be electric ready. And so that includes labeling the panel for the ADU, and it includes providing the electric infrastructure, either at the dryer, at the cooktop, at the furnace, or at the water heater if any of those are non-electric. Okay, we're going to go into a little bit here on some of the new construction for the walls, wall extensions, wall and fenestration, but I am going to circle back around to the water heaters, because those water heater requirements that we just mentioned for electric ready may come into play. And so I'm going to put a pin in that, but then move on to the envelope. Then we'll go to the hot water, then the HVAC side of it. So there's just a couple of things to be aware of for walls and windows. And this is applicable to the new constructions and the additions, which is that the walls, if they're framed, have to meet a specific U value. And not everyone has these U values per climate zone memorized in terms of what they mean. But if you're in climate zone, say 4, you have to have a U factor 0.048, but your climate zone 6, get to bump it up to a 0.065 U factor. So what does that mean in terms of your design, and how do you translate that maybe to your homeowners? I threw in this table for you so that you can take a look at that U factor and get an idea of what that translates into. So for climate zone 4, for example, we could use a 2x6 wall cavity fillet with an R21 cellulose insulation, or an R21 high density bat, include R5 exterior continuous insulation, and that would give us our baseline prescriptive wall. So that's going to look something like this. I've, diagram a scale mock-up. It's going to typically include a rain screen, which would allow that rigid exterior insulation to be able to take care of any sort of vapor diffusion and rain moisture, and allow it to evaporate and dry. So that's sort of best practices. Or if you were to use like a line of products like Durkin, or even Tyvek now makes some special dimple board for stucco, you could do that too, but they all have a rain screen effect. And that's what that would look like for your clients. It's possible to trade those wall assemblies off under the performance method. For the fenestration, the windows, doors, the main thing here, yes, do you have a kind of a code compliant U factor solar heat gain coefficient for our windows? But specifically to the climate zone, the one that seems to throw folks off for ADUs is that the fenestration ratio, window area to conditioned floor area, is still being held to 20%, with a 5% maximum for your west-facing windows. So you can imagine that with a really small footprint, small conditioned floor area, the windows are going to be relatively small as well. And yet a lot of folks who want the ADUs want to see larger windows, so maybe the space doesn't feel as small, or they would just like to have the same size windows they would in the main house, but given the small footprint, you might exceed this prescriptive requirement. So you can use the performance method, the computer energy modeling, to trade it off. However, your project's going to be compared to the 20% window to floor area ratio, which means if you're, and this is what we see commonly for ADUs, is if you're trying to get rid of the exterior insulation requirement and do larger windows, you're automatically going to have to do a computer performance model situation, which now means you have to look for other ways to improve the energy energy features so that overall you have a code compliant ADU for your client. So that's on the new construction side. When it comes to doing your an addition, then what's required for code changes a little bit, and it depends on if it's considered a wall extension, whether they're existing walls or whether they're new walls. So even on an addition, if it's a new wall, you would be using the standard we just reviewed with the continuous exterior insulation. However, if the addition has an extension of an existing wall, the continuous insulation is not required. And then additions that are conversions, like a garage conversion or a bonus room that was part of something else where it was not part of this residence, but the walls exist, then the requirement for those walls is just that you fill the cavity framing with insulation, and the continuous insulation isn't required. So you can see in some situations you might have two different wall types, or you're back to that performance method where you mitigate for the one wall. And then California Energy Commission, through their blueprint newsletter, same link as the one in the previous slide, they have this great graphic that clarifies what that wall extension looks like. And it really does have to be literally in line with the wall. And that is also could be true in the vertical plane if you're adding a second story as well. For the alterations where you have those existing walls, but you now have window replacements, just wanted to point out that for the most part, those window replacements, if you have more than 75 square feet, or if you have that new additional replacements, you're going to comply with the same window standards as new construction. But if you're just doing window replacement and you're only replacing less than 75 square feet, or if you need the skylight replacement as part of this alteration, like for example, you've got an existing master bedroom and you're converting it now to a junior ADU and it requires some wall and window alterations, then the window replacement requirements are slightly less restrictive. And that might give you the ability to get a hold of windows that match the rest of the house. Okay, let's see. We're gonna, before we move on to water heaters, do we have any other questions? And yes, this presentation is being recorded, so you can go back to the 3C Ren website and see it again, and you will get a copy of the slide deck. And also you can reach out to Grant or me through the 3C Ren website for the Code Coach service, and we will answer questions or go into more detail on any of this for you. We're happy to do that. It's really kind of a lot. And so what I see is when folks are working on their projects, they reach out to us through the Code Coach service with that specific part that now they're working on as they're doing their project, their design. One new thing to the code that just 2022 came out is that if you're doing that new construction standalone ADU, it's 500 square feet or less, or you're doing an addition 500 square feet or less, for the first time, you can use an instantaneous electric water heater for that ADU, as long as it has what's called point of use distribution. So, and I'll show you a slide on that. As long as that on-demand electric water heater is right there next to the showers and your sinks, you can now do this. Save space, but it has a higher electric draw than a heat pump. Well, given the small size of the unit, it's going to make it perhaps more cost effective. If your new construction ADU is larger than the 500 square feet, then you would be back to the standard choices for water heating. It could be a gas on demand, or it could be a heat pump. And the heat pumps are typically two types. And if you're going to use the heat pumps, there are some things I want to review with you that are specific to small spaces or small ADUs and small houses.
Now, Jennifer, that is a
Yes.
prescriptive path option only, right?
You can, I clarified in the ACM manual, performance, you can use the point of use distribution on demand electric performance. It's supposed to give you the same baseline. However, what we found is that it doesn't give you a credit. So now you're not getting a credit on your hot water heating. And so we've had situations where folks want to use that electric water heater and they want the bigger windows and they don't want the exterior continuous insulation. And I haven't found enough credits to make all three of those happen. That's where usually the rub is. And so then we're back to talking about a different type of water heater.
And a little bit in the weeds, but I know when this first came out, there were issues in the performance compliance software. Has that been cleared up lately?
As from what I can tell, it has. But I haven't had any projects yet that would be able to comply anyway because of the windows and the walls. So if you have a client and your architect getting used to designing with that exterior continuous insulation and there's a good argument for using it because you've got a smaller, you can think about it this way, you've got a small footprint, small conditioned floor area, and you've got your 6 surfaces, the roof, your floor, and your 4 walls. Now, let's just say you double the size. So you've doubled your floor area, but you haven't doubled your wall surfaces because now you're eliminating 2 of those surfaces. You would have had 2 of those walls when you join 2 of these, sized ADUs together, for example. And so as you grow your conditioned floor area, the ratio of walls of envelope to conditioned floor area, it shifts. So ADUs, they're small and they benefit a lot from having the exterior continuous insulation. It's kind of like the bigger the person, sometimes they don't need as much of a jacket. Houses are a little bit the same way. Small, skinny person, tall, skinny person, can get chilly quicker. So it kind of works the same way. So you might want to keep that exterior insulation and then consider the trade-offs you get on being able to use this type of water heating. Their point of use distribution. So this is a visual example. If you have your electric on-demand water heater, you want to put it close to the bathroom and kitchen sink, washer, dryer, and there are plumbing size pipe lengths and the nominal size and diameters for a line size per length for each run. And you want to take the most direct path. That's part of the code. And there's a way to calculate this if 2 two pipe sizes in a single run. There's a way to calculate it. And you want to, typically what you're going to see is the hot water heater is going to have a 3/4 inch line connection, typical. So you want to manifold that down right away to get to these like 3/8 inch and 1/2 inch runs, which is only needed for your sinks, shower, your typical washing machine. You don't really need to run 3/4 inch water piping out to these fixtures, then neck it down. And this way you save energy. And again, this is if you're going to go all electric and you're going to say, keep that exterior insulation or find other credits. If you are wanting to install a heat pump water heater that's a tank type, or maybe you go instantaneous natural gas and you want to still put that water heater close to your fixtures, you can take a compact plumbing credit or a point of use credit, and HERS Rater would come take a look at that. You would have your CF2Rs, CF3Rs filled out, and that would just be part of that checklist. But you could potentially get a pretty good credit for going ahead to keep the design really compact, so that you might be able to offset, say, that continuous insulation or get bigger windows. So I want to point that out. If you do end up, so here's the caveat that kind of throws folks off with the ADU, new construction, standalone ADU, is if you're doing that standalone new ADU and you decide to go with a gas or propane water heater, you do have to designate a space for a future heat pump water heater. And that space by code has to be 30 inches by 30 inches footprint and then 7 feet tall. And all the components have to be installed with the electric code. And that distance between the gas propane water heater and this designated future heat pump water heater space, those requirements with that are really dependent on whether the distance is less than 3 feet or greater than 3 feet. I'll go into detail on this stuff as much as anyone want, but what I want to tell you is that you're getting a copy of the slides, and so you don't have to dig through every part of the code, but you would get this part pulled out for you, and then you can link to, again, the California Energy Commission blueprint for more clarification and graphics and commonly asked questions, or give us a call at the Code Coach. And these requirements you might want to put on the plan set to make sure that the person doing your electric work, that contractor, sees it. But there's certain specific wiring and labeling for the panel that has to happen. And that's true. Option A, option B, slightly different requirements on the circuitry depending on the distance from your installed gas on-demand water heater when you're opting not to go ahead and do a propane water, do a heat pump water heater. In both cases, you can say, here's the space where I want that future heat pump water heater to go. We've got the electric set up, but there's one other thing that as designers and architects to pay attention to, and that is heat pump water heaters do require condensate drain. Now, this is not the same kind of condensate you get from a gas water heater where it actually is acidic because of the gas combustion. It's a different type. With a heat pump appliance, both space heating and water heating, it condenses water out of the air because the coils are very cold. And so just like water on the outside of a cold glass condenses water and runs down your glass, maybe makes a ring on your table or gets your napkin wet, same sort of thing is happening on the coils with the heat pump water heater and heat pump space heater. So you have to have a way to drain that condensate off. And what that can look like installed for the water heater is a condensate line that comes off from that heat pump, and you can share the same floor drain that you would send your temperature and pressure release valve, just like you would anyway. But you need to make sure that there's a way to drain the condensate for this thing getting installed. And so here's some common ways that could be done. Either that drain's put ahead of time and you know about it, or it's already, the space is designated and close to where maybe you've got your washer dryer if you're doing that unit. And then that condensate drain line could be sent out the same way. This is what it might look like in diagrammatic form for a heat pump water heater, whether you're gonna have a future install, or maybe you choose to install these with your ADU at the same time for your construction. So you're gonna need to allow space for the tank itself, which rule of thumb is 7 foot tall. You probably need an expansion tank with this system, depending on your jurisdiction and what's required for connection to your water supply. And hot water in, cold water out. Cold water in, hot water out. Ambient air in, cold air out. These units do need volume. So here's where it gets tricky for your ADU. The ADU may not have a garage space for this tank to go in. So you might be considering putting it in a closet. And if you put it into a space that is less than 750 to 1,000 cubic feet of volume, you're going to want to use a ducted ventilation kit or follow the manufacturer's recommendations for fully levered doors. And when you do that, these units, even though the tank itself may be inside, technically it's pulling from outside air, so it will impact the requirements. If you end up putting this heat pump water heater inside the ADU and you use the air, the warmer air that's inside the ADU, you'll get better efficiency on these units. So you might consider ducting the cold air out of the house and having a way to have some makeup air that doesn't overly negatively pressurize the ADU. And I have had folks tell me that they've installed these units and they're quiet. And then I've heard accounts where people have said, no, the way it got installed or the unit itself, something about it is too noisy. And it could be that just different folks are sensitive to noise. So I'd say there's two things as a designer to really think about. One is, are your clients sensitive to noise? And two, how do you deal with the fact that the unit, every time it kicks on, will blow cold air-conditioned air into a space? Summertime, it might be wanted. Wintertime, not so much.
We have a
go ahead.
quick question. Dennis asked if space and plumbing for future washer and dryer are required in an ADU.
No, it's not, no, they're not. The electric ready requirements for the, code side of it, it just states that if you install a gas dryer, you have to have the electric infrastructure, so someone in the future could swap it to a, heat pump or condensing or other electric appliance.
I had that as a plan check correction once, and I guess the guy was wrong.
Yeah, unless, Dennis, gosh, unless there's like a different part of the code that's saying that for the ADUs, but that electric ready doesn't mean you have to have space for the dryer. It means if you are installing a gas appliance, you have to have the space and the ability to switch it to electric.
And I would imagine if there's gas stubbed up for a future gas dryer, that would trigger it if someone was looking closely.
Yes, I could see that.
Yeah.
So they'd want to see both. Okay, where's that dryer
had-
going to go in the electric
We
connection?
had one more clarifying question. Arturo asks about heat pump water heaters installed outdoors in an enclosure. So when you're installing a heat pump water heater in the little outdoor closet that's built onto the unit, that's going to be perceived as an outdoor installation in 99% of cases. Like Jennifer was mentioning, there are, with these duct adapter kits, ways that you could show that its intake is from conditioned space. That's a kind of a unique installation option. But otherwise, those will be seen as outdoor installations entirely, and you'll need to have the space or have the duct adapter kit and a louver door. Arturo, if you have additional questions or something more specific, send it in.
And so climate zone dependent, I haven't seen any, and like climate zone 4 want to be outdoors and have those work very well. But like climate zone 6, I've seen it there much more. So one workaround for this is this beautiful little heat pump water heater unit is Sanco 2. They rebranded. It used to be Sandin. This guy is a split system. This is the one that's most readily available in our market currently. There are other brands out there. We used to have one available a number of years ago in California, but it didn't take off. The market didn't pick up enough, so they pulled out. So it may pick up again, but right now Sandin has made effort to rebrand itself as CO2 or Sanco, and the CO2 is because CO2 is the refrigerant for this system, so it's got a very low global warming potential. And I know a lot of folks that's important, especially if they're trying to build a lot of these things to be more environmentally friendly, more green, better for the environment, and really looking at what are we doing in terms of going all electric, but now we're going to put refrigerants into the air. So the Sanco 2 might be your answer. Downside is that it's more expensive, but relatively speaking, it's, you're talking new construction. And so you might spend a couple $1,000s more, but it's only a couple $1,000s over the entire cost of the ADU. So the incremental cost is next to nothing. But what this allows you to do is to mount the outdoor heat pump anywhere. It only needs 15 amp circuit. And then the indoor water heater has none of the noise, none of the cold air situation. And you can really squeeze these into small places and closets, like this one from the Eco2 website just shows it as an understair installation in one case. So super compact. You get a good credit for these because the tanks are indoors. They're meant to work outside already. I think it would just solve a lot of problems for ADUs. That's why I'm talking it up so much. I don't
Yeah,
represent Sandon. I'm not brand specific, but right now they're the only ones on the market.
yeah, they're the only ones doing it, so we kind of have to just talk about that manufacturer when we talk about the split systems. I use those for a lot of custom single family with space restraints. Because it's a single manufacturer specialty system, it does carry a cost premium that is a ever moving number. So just keep that in mind when you're looking into these.
Right, but it's relative, you know, it's
Right.
relative. They install easily.
And
And
it's always changing, so
and
it's hard to give estimates on those things right now.
yeah, so it's shifting. So consider that as an option or a way to kind of work through it. And it's CO2. It's the same CO2 that's in our air that we breathe every day. And it's non-flammable, non-combustible. You can't have too much of it all concentrated in one area because our lungs don't understand an over abundance of CO2 the way our bodies work. So you have to be mindful of that, except that these units, all the CO2 is contained. Here, I'm just going to go back. It's all contained within this outdoor unit. And all of that is held within, like, where, I don't know if you can see my mouse swirling around on the screen, but it's on the right-hand side where the inside of that thing works. It's a very small amount of CO2 to begin with. And yeah, safe. So heat pump for space conditioning and the VCHP, or variable capacity heat pump credit. Before I move on to this credit, if you install those heat pumps, whether it's the integrated type or the split system type, and if it's indoors, often you can get a credit for that. Now, with the ADUs, being that they have a small volume of space, sometimes if you model those as being indoors, you don't get a credit because it's possible to overcool the spaces, right? So you want to go back to that duct ticket. But if you have a larger unit, you can put them indoors. The smaller units, a lot of times you want to keep your tank well protected, well insulated, and keep the water warm, but allow the ducted system to do its job, or do a split system. Now, when it comes to the space conditioning, for new construction, brand new standalone new construction, you're going to need a way to heat and cool the space. You're allowed to do it with gas heating system, and you can, of course, use heat pumps. Prescriptively, meaning what's your performance model going to be compared to? It's dependent on the climate zone, but for climate zones 3, 4, 13, and 14, the heat pump is that sort of baseline that you're going to be compared to. And all the other climate zones, the comparison is based on what you choose. Now, the cost savings for the ADUs really come into play is if you can avoid having to run new gas infrastructure to the ADU. And so, for example, with that Sandon unit, if you don't have to run the gas structure, that Sandon water heater and your heat pumps might cost a little more, but it's going to be offset by not having to run that gas infrastructure out to that ADU. It's a little different if it's an addition or the JADUs. And just to kind of be clear, I threw the slide in here too, especially if you're communicating to your clients and they're not sure what these are when you're talking about mini splits. This diagram just to say, hey, you're going to have your outdoor compressor condenser. It's like a skinny size, like suitcase, so smaller than a regular air conditioner. And then you're going to have your, the line set that includes like that condensate drain, the communication lines, and your refrigerant lines. They're going to run into the indoor units, and those can be wall mounted or ceiling, recessed ceiling mounted. So the important thing to remember for the heating and cooling in ADUs is that they may not share the return air with the primary dwelling through that heating and cooling system, and they have to have the separate thermostats. So one nice thing about these split systems is you can have one outdoor unit that can work with several indoor units, and then each of those indoor units, since there is no return air, the air simply stays within the indoor unit itself. You can meet this requirement and have separate units. And this is what it could look like in a remodel situation if you're doing an addition or creating a JADU. This was a raised floor example where the new mini split got mounted outdoors, and then they were able to run those line set just under the house and pop it up into the new area. With the variable, looking for credits in the performance method, because maybe you're going to have extra large windows and perhaps you weren't able to get quite as good of a credit on the water heating side as you had hoped for. And you're contemplating that exterior wall insulation, et cetera, et cetera. It's possible to use these mini splits and get the variable capacity heat pump compliance credit. And just be forewarned that it does require a lot of HERS measures and a lot of things are triggered, but it's a good credit. You'll see it in the special features section. The variable capacity heat pump compliance option is called out. The HERS feature summary on your CF1R is going to trigger all of these verification of refrigerant charge, efficiency, airflow to each habitable room, capacities, and thermostats. And this, I threw this one in here in case we had any of the, anyone from jurisdictions or homeowners or builders on the call, is that the best time to call your HERS rater out there when you're installing these is during the setup, because they set up within hours. It's quick. And when they do the verification of the refrigerant charge, that HERS rater can be there and can see it and take care of it all at the same time. From a designer's kind of the design perspective, is that in order to receive this credit, you would want to make sure that you show a indoor unit to each habitable room. So that would mean each bedroom has to have one, even for small dwellings. For Title 24, each bedroom would have one, and the living area would have one. And then the wall thermostats, they're required in zones larger than 150 square feet. So it's possible to have these installed within the continuous air and thermal boundary, and then have those penetrations of the line set and your condensation line air sealed, and then do these other things, and you would get a good credit on your performance model. And just to kind of point out too, for the architects and just kind of design options, some folks don't like the way those wall units mounted. They have other ways of doing it. We're starting to see more of the ceiling recessed type. And for the architects, if you're working with your energy consultant and you know that you're going to need this credit, then you want to show your detailing that these recessed ductless units are within the continuous air and thermal boundary. So what that means is if you have an attic on the ADU, you're going to want to explicitly say that that recessed unit needs to be covered with a box made for that purpose, or you can use taped and sealed drywall as an air barrier and create a cavity for it, and then have the code compliant amount of ceiling insulation go up and over that unit. Or you could do an unvented attic assembly, for example, or a semi-conditioned unvented attic. Okay. Any maybe questions on any of that?
Not yet.
Okay. Oh gosh, I just glanced over and saw cost comparison, gas and electric.
Yeah,
And
that was
yeah, there's yeah, we could talk more about that after I finish up the last little bit of slides, because
yeah, Jennifer's done a bunch of work with that stuff and seen the differences for small single family or ADUs. So that'd be a good item that we can chat about at the end if we want.
yeah, that sounds great. Okay, so one of the kind of the last things to be aware of specific to ADUs and their size is that, just FYI, you know, kind of big reminder, ventilation, indoor air quality, or also known IAQ. Outside air is required. It's still the case where you can't consider an open window as the sole way of providing outside air. So you do have to show that you're meeting the outside air requirements with a mechanical ventilation. And ASHRAE 62.2 continues to be the basis for that. And then all of the requirements in section 150.0 for new construction and additions greater than 1,000 square feet apply. And then when it comes to smaller additions, then it wouldn't necessarily trigger all of these requirements. If you're having cooking facilities, gas or electric range top, specifically the range, then it's going to trigger a kitchen hood. And the new to the 2022 code is that the kitchen hood is to be sized per dwelling unit floor area and whether you're cooking over electric or gas or propane. So if it's natural gas, propane, the ventilation hood has to be larger in terms of the CFM exhaust, or what's known as the capture efficiency. And if you're cooking over electric, they could be smaller. And you might notice that the larger the dwelling unit, the smaller the CFM, or cubic feet per minute, needs to be. And so what this is a direct result of is a lot of studies done by the EPA and marked statistically significant increase in asthma for people that are in smaller dwellings, not getting enough air circulation. So the smaller the dwelling, the more concentrated. And sometimes it's true that the smaller the dwelling, the more people you have, and also the more cooking that's going on. So the air pollution tanks, essentially. So this is HERS Cal Green, now part of the energy code. HERS, this is part of baked in already. You can't get out of these HERS verification. And so they'll look for the capture efficiency, and they'll look for the SONS rating as well. And that needs to be met. There's also a new part of the code, prescriptive duct sizing for the kitchen exhaust. And there's don't make the total length more than 25 feet. Don't have more than 3 elbows. Make sure the exterior termination fittings are proper. Because it's a prescriptive requirement, you don't have to do it this way. But in an ADU, I don't see why you wouldn't be able to do that. But in some cases, maybe you can't, then you can field test it to prove that all these requirements are being met. And I threw in this slide here for you so that you can have this formula handy to calculate the amount of outside air that's required, where it's based on the conditioned floor area and number of bedrooms. And we're seeing this comes up a lot. There is a way to reduce this outside air requirement based on how leaky the envelope is, how much infiltration and exfiltration it has. But this assumes that all the ventilation would come from your mechanical means, which is the rule of thumb. We recommend you follow this formula. You might be ever so slightly overventilated.
Jennifer, we had a
Yes.
Cooktop venting question. Is there any allowance for a non-venting exhaust hood in the code anymore?
If you have a non-venting exhaust hood, you would still, it's an CFM or capture efficiency. That CFM requirement still kicks in. And we have seen, not on purpose, the architect called out the venting exhaust hood. The builder decided they could save some money because they're used to building apartments this way. It applies to ADUs too. So they didn't connect it to the outdoors. They used the version of the same hood that just was a recirculation hood right over the cooktop. And the fix is you have to install a fan in the kitchen that exhausts the same amount of CFM as what would have been required.
So the answer is no. If you want to use the forehead greaser and then still have additional exhaust, that is acceptable. I believe you can even just use the exhaust alone if you wanted to, but no matter what, you have to meet that kitchen ventilation exhaust requirement with an actual vented duct.
Yeah, and what we're seeing, like additions, alterations, to bring some of these things up to code or remodeling. It could be maybe that kitchen exists, but now you can bring it up to code by adding in a wall fan that does the same amount of CFM pull.
Yeah, thanks.
And the whole concept of balanced ventilation for IAQ. I mean, really what we're saying is we want to avoid uncontrolled air infiltration and exfiltration. We're trying to avoid a leaky envelope. In general, this is where the code's been going. Air leakage sealing has been a mandatory requirement for many, many years now. And HERS QII, HERS quality insulation installation, is now prescriptively required under the new 2022 code, meaning that if you don't do it, you take a penalty. And so, especially with ADUs, we're already looking at, bigger windows. Typically, the wall insulation in our climate zones keeps coming up. Some folks don't want to do QII. There's another penalty. So basically, you're going to run out of ways to get extra credit to make up for it. So we're seeing QII on all our projects. QII includes visual confirmation of all the air sealing. So balanced ventilation is becoming more and more important because it doesn't depend on the leaky envelope. And in a real simple sense, balanced ventilation means supply air in and exhaust air out. And yes, they could be two separate fans, but they need to be interconnected and linked together like this one brand does. Or you can do something that's going to give you better energy performance, and it's all in one unit meant for the purpose. And they do make some now that work great with small dwellings, like this Fresh R unit that's now available, I think 475 website. They're just bringing it to market now. It's been available in Europe for a long time. And then Lunos is available here. Twin Fresh, I see that one now around similar concept as Lunos. And these are what's called spot ventilation. And you can put these you can do them in pairs and have one in one part of the ADU and one in another part of the ADU, and they'll work together. Or you could do something like this Panasonic ERV that recesses into the ceiling. And these are very common, work great for small spaces. You can do them for large homes too, you just need more of them. But for ADUs, these could be a great solution. These meet your indoor air quality requirements. If your particular project, however, needs some performance credit and you want to consider ERV or HRV for that as a performance credit, then you would need to choose a unit that's actually listed on the HVI.org website, Home Ventilation Institute website. So the CEC refers you back to that, and you can go through with a HERS mechanical ventilation and indoor air quality credit. And this is a unit, this thing, gosh, it's about 16 inches wide, could be 24 to 30 inches tall, 10 inches deep. It really depends on the size you need. They're kind of large, but this is from a multifamily project that we worked on, the apartments, and they installed these behind a louvered door, easily accessible, kind of waist height, so you could change the filters and do maintenance on it. But then this allowed those dwelling units to take credit. And the same thing could apply to an ADU if you were so inclined. Kind of the last two things I want to leave you with, and then we have a few moments for questions and a review of the topics coming up, is that as kind of an architect side of it, because we've got a lot going on now with potential HERS measures that are required on the project. It's if these HERS measures get missed by the builder and the installing contractors, it's going to be really hard to go back and find credit someplace else to make up for these missing measures. So I keep ending a lot of these presentations reminding folks that, like, on the cover sheet for their ADU, that they include a category, and it might be just supporting documents. You could call it code summary, code analysis, the HERS summary, that you list specifically which credits that this project is going for, to just really keep alerting the builder and everyone else that at least is looking at the cover sheet that they need to be mindful of, say, QII or the HERS VCHP, variable capacity heat pump credit, and perhaps the ERV or HRV balanced ventilation. Those seem to be the main ones that get missed. And if you have any more questions for us, please reach out through 3cren.org codes or call the hotline number, and we're here to answer your code coach questions. And then with that, we've got a closing slide on upcoming performances that upcoming presentations that Naomi will go over. And then we'll have like a minute or two to address some of the costs or any other questions folks have.
Yeah, thanks, Jennifer. So as we mentioned before, there are education units available for this course. If you have any questions, feel free to email me. And a reminder to take a look at some upcoming courses that are coming up, some that are in person. And I'm going to launch a poll. If you could fill that out, that would be great. Just evaluating today's course. And then I'll pass it back to you, Jennifer and Grant, for any questions.
Yeah, go ahead. Or if there's something in the chat or any questions, you can unmute if that's easier, or raise your hand. And then depending on Naomi's timing, we could stay on the line for a couple extra minutes if folks have questions. But anyone who needs to jump off at 11, yeah, please feel free to do so. Don't let us hang you up.
I can touch on Glenn's question in my response, see if you have anything to add. He was just asking about the comparable costs from gas to heat pump water heaters, not including solar. So just strictly 1-to-1. It's highly dependent on electricity rates and gas rates in your area. So depending on the location, that usually dictates the difference in a lot of cases. But what we've seen is that it's pretty much cost neutral. And then I talked about the integral electric resistance backup that, depending on installation and controls and the demand of the occupants, and if it was sized correctly for that demand, if that's getting kicked on frequently, that'll bust the cost comparison, and you're going to spend more on electricity in that case. So but that's really a design consideration, and if the units are operating properly, then we see them as generally cost neutral, and in some cases being more efficient.
Yeah, with the cost with water heating, electric and gas, it really depends on your location. And then it also depends, because of the electric rates, it also depends on if you're getting the most efficiency out of your heat pump water heater. So I just recently was listening to someone who was vlogging about their own experience with a heat pump water heater compared to their old gas tank type. And I thought it was interesting because they had commented that they knew they didn't have the recommended volume of airspace around their heat pump water heater. And they explicitly said that the room was less than the 700 square feet, and it felt like a meat locker in there. So the heat pump's working against itself. Even then, they were charting their heat pump electric use. They were comparing it to a prior year when they still had gas. And yes, they were using more electricity during a couple of the shoulder months for heating their water heater. For heating their hot water with electric. But even then, the cost difference was like $10 a month more, $12 a month more. So yes, that could be 20% more expensive, 25% more expensive, but it's still only $10. So you got to look at your whole budget. Like, is that? And most of the months it was coming out a wash. Now they have high gas prices in their area. They're over $2 a therm. And then their electric prices was still, this was a year ago, so their electric prices was still like around the 32 cents a kilowatt hour. Now, I just recently took a look at my own rates, and I'm up in PG&E, North County, and my electric rate now, it's 58. I'm charging a lot of 58 cents a kilowatt hour. So it's almost double, and my gas price hasn't doubled. So, you know, cost effectiveness means getting my PVs and battery system installed. It's the next thing on my own personal journey to an all electric house. Test it out on myself before I tell everyone else about it. So it really, it's depends. So what's going to happen with your clients, I think with these ADUs, some of the big cost implication are going to come down to, do you already have the gas infrastructure in place? Or are you looking at like $10,000 to $20,000 to run the gas system out there?
Yeah.
And then knowing that the cost difference between operationally gas and electric is, even if the electric's a little more right now, with the new construction, they may be compelled to do a PV battery system anyway. Then again, the cost comparison between the gas and the electric is going to mitigate.
Yeah, and there's just a lot of variables, including, you know, electric vehicle and what your total electricity rate structure and total demand is. So
That's
it's
true.
hard,
I have three
it's hard to,
teenagers in
it's
my
hard
house.
to, yeah, it's hard to generally just say, but a lot of the studies we've done and the data we've gotten is that we're talking in the quantities of $10 differences one way or the other. So I usually just tend to say they're very neutral these days, you know, barring the other cases.
Right, right. Yeah. And
Okay, we're not
yeah,
getting any questions, so
okay.
I think we can close up. Thanks everyone for attending.
Thank you, everyone. I really appreciate your attendance, and hopefully you can join us for the next one.
Yeah, thank you, anyone. A reminder that you can contact us for more info at 3crun.org. We're also email info@3crun.org. But thank you so much, Jennifer and Grant, for this great training. And yeah, hope to see you in a training soon, everyone. Bye.
Okay, thank you. Bye.